Remember, you want to trim your cone. There you go, work with it.
And so what's our example translation? Be able to kind of map and know what their position is and know they can't just slide this way or slide that way. We have a cohort for teachers who teach students with disabilities. We call it the ECE Coohort. It's really to help them with the math.
We're going to test out one of these lessons today. Where I'm going to show you the process, and then we're going to actually work. You're going to do the lesson as you were a student. ECE teachers are trained to be strategy experts, but not necessarily trained to be experts in the content areas. And so a focus just on mathematics education and what is the mathematics content that we're teaching was needed. We have roughly 12 teachers who are all ECE certified, special ed certified, who come to us about once a month, and we work on mathematics. And it's not just the content. We talk about, strategies and pedagogy, but the main purpose is to focus on what are the content standards and how do we make sense of them with our ECE students without decreasing the rigor, but how do we help them be successful with the standards. So in this investigation, we're going to be looking at the relationship between the volume of the cone and a volume of a cylinder. So right now, your kids they've got a framework. Part of our structure is that for every unit they have coming up, we create what we call a unit at a glance. I put in the unit at a glance clear opportunities for you to practice. Remember, it's not just about, the standard is not just about them knowing the formula. It's about them being able to apply it in what kind of situations?
In a real world.
Real world and mathematical. Those are two different things. And it's a unit document that pulls together standards, learning targets, IEP goals that could be associated with those.
Well, I think it's great for teachers to see models. We go through the curriculum, we model how they can teach it. We show them what a lesson could look like.
We always try to take the standards and then we create our unit at a glance, and then we try to offer experiences during the cohort so the teachers are experiencing the standards the way we want our students to experience the standards. So on this one, you have a glass, but I want everybody to take a look at the glasses first. We're going to need to make sure that when we're measuring, that we're trying to measure from the space, the actual bottom of the cylinder and not the base of the glass, okay? Looking at 8G9, it's focusing on volume of cylinders, cones, and spheres. So you're going to take a piece of paper and you're going to roll it into a cone so that you have a point that hits the base of the glass, like inside the glass, and so that the cone itself opens up flush with the edge of the glass. It takes a little bit of time, but I promise you, you can do it. Closer, there you go. So now I would adjust. So maybe, because right now we're kind of rolling more of a cylinder, so maybe what we need to do is kind of start from a triangle, because this is the piece this is what we want, right? So maybe try to start there and then just tighten as you need to. But remember, you have a lot of time to teach this unit. I think the hands-on is so exciting, and that's good, Jackie. All right, so it can be done. We've got one.
Hey, way to go.
Do I cut it now?
Yes. Okay, so once you have your cone, you want to cut it off and trim it so that the height of the cone is the same as what? The height of the cylinder. So we should have at least one cone for every table with a cylinder, with a matching cylinder. So remember the volume. What is volume? How is volume different than area? How is measuring volume different than area?
It's a third dimension.
It's a third dimension. So what makes it a third dimension?
The height.
The height, the shape. Okay, so volume can kind of be expressed as layering, like we've talked about before. And you and your students will have talked a lot about this idea of layering, right? But it's also filling.
ECE students are very concrete in their thinking, and we really want them to be able to think like the standards want us to think with the mathematical practices. We want them to attend to precision. We want them to persevere. Often our students will just give up. If I don't get it right away, I'm done. I don't have to do anything else. I need help. And so we really want our students to persevere. We want them to pay attention to what they're doing and really be good thinkers and not just so concrete and thinking about everything, but get more abstract. And so that's a skill that we have to teach our teachers first so they can even model that for their students.
Okay, so now what you're going to do is you're going to take some rice and carefully pour rice into your cone and fill up your cone. Woo. I'm not going to go all the way because I don't want it to spill over. And then you're going to dump. Once you've got your rice in your cone, this would be the volume of the cone, right? This rice would represent the volume of the cone. But we don't want to have to get out and count each grain of rice. So we want to come up with a formula, systematic way of calculating this volume. So you're going to take your volume of the cone and you're going to dump it into your cylinder. And you're going to do this however many times you need to until the cylinder is filled. And we're going to be looking for, again, like we did with the sphere, the relationship between the volume of the cone and the volume of the cylinder. We're going to be collecting data on the height of your cylinder. So you're going to need to measure the height of your cylinder, how many times it took to fill your cone or fill your cylinder with your cone of rice. And then we're going to figure out the volume of the cylinder and the volume of the cone. Okay, does everybody understand the task? How many cones does it take to fill the cylinder? All right, I'm gonna let you take over. No, you're okay. Remember, it's an estimate because remember we had to account for the glass. So, about what? 2.5. About 2.5? And we're just looking for that general relationship. You guys might start to see, as Kirsten's putting up her information, a relationship between these numbers. And remember, we're thinking about these numbers the same way we did with the sphere in our last investigation. Are we noticing any relationship between the number of times that it took to fill the cone or fill the cylinder using the cone? They're all pretty similar. They're all like really similar. This is much nicer data than our last data set, isn't it?
Number 2.
Except for number 2. What's wrong with number 2?
Number 2, they instead of doing half of the diameter, they did half the height and squared that.
Oh, was that your group that did that? And you looked at their numbers and discerned that?
Yeah, we figured it out.
Nice.
He
Okay,
did
so
it
this is a good example in your classroom where this could be like a really contentious moment with students, right? Where, well, you all did that wrong, But like what's happened is your group making a mistake has actually given a gift to this group of them being able to puzzle and figure out what happened. And they were able to analyze your work, which is showing me that they really understand the formula. So I think it's just about like making sure that you have an environment where you can celebrate those kind of things. So we're still showing the difference between the cylinders because now we see all of these should be about the same, right? But this one's way off, so now we know, oh, there must be a problem here. So they took half of the height instead of half of the diameter. Nice job. You don't stand up at the board and teach the mathematical practices. You offer experiences for students to stumble upon a practice and then realize the benefit of it. Okay, so about how many times did it take the cone, the volume of the cone, to fill up the volume of the sphere?
About 3.
About 3. So what's a relationship, what's a statement that we could make about the volume of a cone and the volume of a cylinder?
The volume of the cone is 1/3 the volume of a cylinder, right?
I think
Very-
another way you could say it is the volume of the cylinder is 3 times greater than the volume of the cone.
Woohoo! Great! Okay, so that's awesome. And that is not an unreasonable statement to expect our students to make. But we have to ask the question. That is a great way to really get at the meaning of 1/3 and what would be the inverse of that.
So I think this is really great for our teachers so they're not scared of the math, that they are equipped to go back and teach their students, because sometimes students don't have a good understanding because their teachers didn't have a good understanding. So I think this is a really valuable thing for our district, and I'm just glad that we do it.
We build retention by showing them lots of different experiences with the same idea in different contexts, in different mathematical situations.
Often with ECE teachers, we teach our students strategies, tricks, tips, mnemonics to kind of remember things. With standards, you're not just remembering.
What would our formula be for volume of a cone? We already know the relationship, we wrote it up there. Just showing them the value
Let's start with what our
of not only
cylinder
them
was.
being able to create the formula for themselves and see the relationship between the cone and the cylinder, but then from there being able to reason through why is the formula what it is, and that really gets at the mathematical practices and at the meaning of the standard. Okay, so we know we have pi r squared times height. You can move those around any way you want. And that's our volume of a cylinder. So what needs to happen to this formula to make the volume of the cone?
The volume.
Right, so divide it by 3 is one way to do it. Awesome. I love that representation. What's another way we could express this? Equivalent expressions.
Times 1.
This is the same thing as pi r squared height. Nice. It was so perfect when we got all the data up there, and they all saw the relationships between the numbers, and so they were making generalizations. They were working on practice 8, and then Vitalis says, well, gosh, and this is an adult, he says, well, when I go get ice cream now, I'm gonna get it in a cylinder instead of a cone because I'm gonna get 3 times more.
But 3 times more than the ice cream in the cone. If the cup and the ice cream are the same height, then I should go with the cup because it's 3 times more than the ice cream in the cone.
That is such a good point, Vitalis. Did everybody catch that? We were all just like, yes, so those are the types of experiences that you can't teach. I mean, I didn't plan for that to happen. You have to set up the experience so then kids can make meaning of the mathematics on their own and realize the benefit of a practice that they've used. That's fantastic. Great. So share that example with your students. Great job, Vitalis. It's important because we're creating problem solvers. They're going to be able to go out into the world and lead our nation eventually. And so we need to have students who can, persevere through a problem. And I think when you look at ECE students in general, a lot of times they haven't been pushed to persevere. And so this group of teachers that we're working with specifically, we're pushing them out of their comfort zone, and they're in turn pushing their students out of their comfort zone, but there's no reason why all of those students can't be successful with mathematics.